There is a $4 bucket of white elastomeric coating at every hardware store in your country right now that bonds to any roof surface, seals every crack and seam permanently, reflects 85% of all solar heat, and keeps water out of your home for up to 20 years without a single reapplication. No tear-off, no new shingles, no plywood replacement. No crew of 6 men spending a week on your roof while you write a check for $8,000 to $15,000. Just a thick white coating rolled directly over your existing roof surface that cures into a seamless, flexible, waterproof rubber membrane that expands and contracts with every temperature swing and never cracks, never peels, and never lets a single drop of water through. The United States Department of Energy has documented the thermal performance of reflective roof coatings in published research, confirming energy savings of 10 to 40% on cooling costs alone. Oak Ridge National Laboratory tested elastomeric coatings under extreme accelerated weathering conditions and published data, confirming functional waterproofing integrity beyond 20 years. The Environmental Protection Agency's Energy Star program has certified reflective roof coatings as a recommended energy-saving technology for residential and commercial buildings. This is not a temporary patch from a tube squeezed over a leak. Ancient civilizations across the Middle East waterproofed flat rooftops with lime and natural bitumen coatings over 5,000 years ago. Roman engineers sealed the roofs of aqueducts, cisterns, and public buildings using a volcanic ash concrete coating that has remained waterproof for nearly 2,000 years. Indigenous peoples across Central America waterproofed thatched and timber roofs with tree resin, coatings that survived centuries of tropical monsoon conditions. Then, a $56 billion roofing industry realized something very dangerous. They realized that a $4 coating applied in an afternoon could extend any existing roof's functional life by 15 to 20 years, eliminating the most profitable transaction in their entire business model. They did not stop using elastomeric coatings because they failed. The commercial roofing sector uses the exact same chemistry on billion-dollar facilities every single day. They stopped telling homeowners about it because a $4 coating that works for 2 decades cannot coexist with an $8,000 tear-off and replacement cycle that repeats every 20 to 25 years. And anything that doubles the life of a roof at 1,000th the price of replacement must be kept out of the homeowner's vocabulary. This is the story of the cheapest roof waterproofing method that polymer science allows, and the massive industry that needs your roof to fail on schedule so they can sell you a new one. If you are not subscribed yet, hit subscribe and the bell right now. What they buried, we dig up, every single video. Travel back with me to approximately 3000 BC, the ancient city of Mohenjo-Daro, in the Indus Valley, modern-day Pakistan. Engineers of the Indus Valley civilization are constructing the Great Bath, a large public water structure that requires absolute waterproofing across every surface, including the surrounding roof structures that protect the facility. They develop a coating made from natural bitumen, a thick, tar-like petroleum substance that seeps from the ground in certain regions of the ancient world. They heat the bitumen until it flows, mix it with mineral phyllite and plant fibers for flexibility and strength, and apply it in thick layers across flat roof surfaces and the interior walls of the bath. The coating cures into a seamless, flexible, waterproof membrane that bonds to the underlying masonry and seals every joint, every crack, and every pore. When archaeologists excavated Mohenjo-Daro in the 1920s, they found this bitumen coating still intact, still adhered to the masonry surfaces, still waterproof after 5,000 years. 5,000 years of waterproof performance from a coating applied by hand to a flat roof surface in the Bronze Age. Now move to ancient Mesopotamia. The same era across the Tigris and Euphrates river valleys. Sumerian and later Babylonian builders routinely waterproofed flat-roofed mud brick buildings using bitumen coatings applied in multiple layers. The city of Ur, one of the most important cities in the ancient world, featured thousands of flat-roofed structures sealed with bitumen that protected mud brick walls from the destructive monsoon rains. The ancient Babylonians refined the technique to an engineering standard. They documented specific application thicknesses. They specified multiple coat systems for maximum durability. They developed reinforcement techniques using woven reed mats embedded between bitumen layers, creating what is functionally identical to a modern reinforced membrane roofing system. This was not primitive waterproofing. This was engineered roof coating technology. documented on clay tablets in cuneiform script over 4,000 years ago. Now cross to the Roman Empire, the engineering apex of the ancient world. Roman engineers developed a coating material that modern science has only recently begun to fully understand. Opus signinum, a mixture of lime, volcanic ash from the region of Pozzuoli near Mount Vesuvius, and crushed pottery fragments, applied as a thick coating to roofs, cisterns, aqueducts, and any surface that required permanent waterproofing. When this mixture cures, the volcanic ash reacts with the lime in the presence of water to form calcium aluminum silicate hydrate crystals, the same pozzolanic reaction that gives Roman concrete its legendary durability. The coating becomes harder, denser, and more waterproof over time as the crystalline reaction continues developing for months and years after application. Roman cisterns coated with opus signinum have been found across the Mediterranean with their waterproof coatings still functional after 2,000 years of continuous water contact. Aqueducts sealed with this material carried millions of gallons of water across hundreds of miles with zero leakage for centuries. 2,000 years of waterproof service from a coating applied with a trowel. Now move to traditional building practices across the Middle East and North Africa. For thousands of years, flat-roofed buildings across Morocco, Tunisia, Egypt, Syria, and Iran have been waterproofed using lime-based coatings applied in thick layers and renewed periodically. The white lime coating serves dual purpose. It waterproofs the roof surface against seasonal rains, and it reflects solar radiation, dramatically reducing interior temperatures during brutal summer months. The white rooftops of Santorini, the Medinas of Morocco, the ancient quarters of Damascus. Every iconic white-roofed Mediterranean and Middle Eastern cityscape you have ever seen exists because of a roof coating technology that costs almost nothing, lasts for years between applications, and has been protecting buildings since before the pyramids were completed. Every civilization that built flat or low-slope roofs independently discovered the same fundamental truth. A thick, flexible, reflective coating applied directly to the roof surface provides superior waterproofing at a fraction of the cost of structural replacement, and for thousands of years, this was standard practice everywhere on Earth. Then the modern roofing industry arrived, and it replaced a $4 coating with a $12,000 installation cycle that repeats every 20 to 25 years for the life of the building. The modern science behind this $4 coating is where the story becomes absolutely devastating to the roofing industry. The product is elastomeric roof coating, a thick, white, liquid-applied membrane that cures into a seamless, flexible, waterproof layer directly over existing roof surfaces. The base chemistry is acrylic polymer emulsion, the same fundamental polymer technology used in exterior house paint, but formulated at dramatically higher solids content and film thickness specifically for roof waterproofing applications. Here is what happens at the molecular level when elastomeric coating cures on a roof surface. The coating is applied as a thick liquid suspension of acrylic polymer particles in water. As the water evaporates, the polymer particles pack together and coalesce into a continuous, seamless film. The individual particles fuse at the molecular level, forming long polymer chains that cross-link into a unified elastic membrane. This membrane has three critical properties that make it extraordinarily effective as a roof waterproofing system. First, it is seamless. Unlike shingles, which have thousands of individual overlapping pieces, creating thousands of potential leak pathways at every edge, nail, hole, and seam, an elastomeric coating cures into a single continuous membrane with zero seams, zero edges, and zero fastener penetration. Water has no pathway through a seamless surface. There are no joints to separate, no nails to back out, no shingle tabs to lift in wind. Second, it is elastic. The cured membrane can stretch 200 to 400% beyond its original dimension without cracking or tearing. This is critical because roof surfaces expand and contract constantly with temperature changes. A roof surface in direct sunlight can reach 160 degrees Fahrenheit during a summer afternoon and drop to 30 degrees the following winter night. That thermal cycling creates enormous expansion and contraction stress that cracks rigid materials. Asphalt shingles are rigid. They crack under thermal cycling. That is why shingle roofs develop leaks over time. The material cannot keep up with the movement. Elastomeric coating moves with the roof. It stretches when the surface expands in heat. It contracts when the surface shrinks in cold. It never cracks because it was engineered to flex. The membrane maintains waterproof integrity through thousands of thermal cycles that would destroy any rigid roofing material. Third, it is reflective. A white elastomeric coating reflects 80 to 90% of incoming solar radiation. A standard dark asphalt shingle roof absorbs 80 to 90%. The difference in surface temperature between a coated and uncoated roof on a sunny day can exceed 60 degrees Fahrenheit. This reflectivity has two extraordinary benefits. It dramatically reduces cooling costs. The Department of Energy documented that reflective roof coatings reduce cooling energy consumption by 10 to 40%, depending on climate zone, building insulation, and roof area. For a typical home spending $1,200 per year on cooling, that represents $120 to $480 in annual savings. Over the 20-year life of the coating, that is, $2,400 to $9,600 in energy savings from a $4 coating. It also dramatically reduces thermal stress on the roof surface itself. A cooler roof experiences less expansion and contraction cycling. Less cycling means less material fatigue. Less fatigue means longer life for both the coating and the roof structure underneath. Reflective coatings extend the life of the underlying roof material by reducing the thermal punishment it endures every single day. You are not just waterproofing your roof. You are extending its total lifespan while simultaneously cutting your energy bills. From a $4 bucket of white coating, now here is the data that the roofing industry truly does not want you to see. A 2012 study by the Lawrence Berkeley National Laboratory, one of the Department of Energy's premier research facilities, analyzed the life cycle performance of reflective roof coatings applied to existing roofs. The researchers found that coatings extended roof service life by an average of 10 to 15 years beyond the original expected lifespan of the underlying roof system. A roof expected to last 20 years lasts 30 to 35 with a reflective coating. A roof nearing the end of its expected life gets an additional decade or more of functional service. Not from a $12,000 replacement, from a coating that costs a fraction of 1% of replacement price. The National Roofing Contractors Association published data showing that roof coatings applied to commercial buildings have maintained waterproof performance for 15 to 20 years in documented case studies. These are real buildings in real weather conditions, with real performance data tracked over decades. The U.S. military has used elastomeric roof coatings on bases across every climate zone from Arctic, Alaska to tropical Guam. Military facilities management data confirms decades of waterproof performance from coating, systems that cost a fraction of full roof replacement. If elastomeric coating is reliable enough for a military installation housing critical defense infrastructure, it is reliable enough for your house. So if elastomeric roof coatings are documented by DOE, tested by Lawrence Berkeley National Laboratory, certified by Energy Star, used by the military, proven for 20 years in field conditions, and cost $4 per gallon, why does every roofing company recommend AI $2,000 to $15,000? Tear-off and replacement instead of a $50 to $200 coating job? The answer is the most straightforward version of the same answer it always is. The U.S. roofing industry generates over $56 billion in annual revenue. Residential roof replacement represents the single largest revenue category in that market. The average residential roof replacement costs between $8,000 and $15,000 for a standard asphalt shingle system. For premium materials, $15,000 to $30,000 or more. The roofing industry's entire business model is built around a predictable replacement cycle. Asphalt shingle manufacturers rate their products for 20 to 30-year lifespans. When that lifespan expires, the homeowner replaces the roof. The cycle repeats for as long as the building exists. Now consider what happens if homeowners discover that a $50 to $200 coating applied in one afternoon can extend their existing roof by 15 to 20 years. A homeowner whose roof is 15 years into a 20-year lifespan faces two options. Option 1, wait 5 years and pay $12,000 for a full replacement. Option 2, spend $100 on coating this weekend and get 15 to 20 more years of waterproof service from the existing roof. If even 30% of homeowners facing roof replacement chose coating instead, that represents roughly $5 to $8 billion in annual revenue that evaporates from the roofing industry overnight. That is not a theoretical number. That is the real financial impact of a $4 coating on a $56 billion industry. And it explains perfectly why every roofing company that knocks on your door talks about replacement and never mentions coating. The conflict of interest is structural and total. Roofing contractors make money tearing off old roofs and installing new ones. The more roofs they replace, the more money they make. A coating that prevents the need for replacement does not just reduce their income, it eliminates their reason for being on your property. A roofer who recommends coating over replacement is recommending a $100 job instead of a $12,000 job. No business on earth voluntarily reduces its revenue by 99% on every transaction. So instead of coating, they offer you a free roof inspection. They find wear. They find granule loss. They find minor flashing issues, all normal aging conditions that coating addresses beautifully. And they present these conditions as evidence that full replacement is your only responsible option. They show you manufacturer data about shingle lifespan ratings. They cite building codes that specify material requirements. They talk about warranty coverage that only applies to new installations. Every word is technically accurate, and every word is designed to steer you toward the $12,000 option and away from the $100 one. The information is not false. It is selectively presented, and selective presentation by a party with a $12,000 financial interest in your decision is not education. It is sales. If you have made it this far, you already understand more about roof waterproofing than 99% of homeowners who will write a $12,000 check this year for a roof that could have been saved with a weekend afternoon and a paint roller. Subscribe and share this video with someone who deserves to know before the roofing companies. Truck pulls into their driveway. Stay with me now because the most important part of this video is next. Now, I need to be completely honest with you here. Elastomeric roof coating is not a solution for every roof in every condition. If your roof has severe structural damage, rotted decking, sagging areas, or widespread mold growth in the attic from prolonged water intrusion, those problems must be addressed structurally before any coating is applied. Coating over structural damage seals the problem inside and makes it worse. If your shingles have lost the majority of their granule surface and the asphalt mat is exposed and brittle across large areas, the coating may not bond reliably to the deteriorated surface. Severely degraded substrates may require localized repair or partial replacement before coating. Coating also works best on flat and low-slope roofs where the material can be applied at proper thickness without running. On steep slope roofs, application technique must be adjusted and thicker formulations may be required. And elastomeric coating requires proper application thickness to achieve rated performance. 2 coats at manufacturer-specified coverage rates is the minimum. Thin, single-coat application will not deliver 20-year waterproofing. Follow the product directions on thickness, and you will get the rated performance. But here is what elastomeric coating absolutely does, and does exceptionally well. It creates a seamless, elastic, waterproof membrane over your entire existing roof surface. It bridges and seals existing cracks up to 1/8 inch wide. It seals around every flashing vent, pipe, and skylight penetration. It reflects 80 to 90% of solar heat, cutting cooling costs by 10 to 40%. It extends roof service life by 10 to 20 years. It can be recoated at any time to extend performance further. And it costs roughly 1 to 2% of full roof replacement. For the 70% of roof replacements that are driven by leaks and weathering rather than structural failure, coating is not just cheaper, it is the more appropriate solution. Here's exactly what to do with this knowledge starting today. Step 1. Inspect your roof. Get on your roof safely, or hire a home inspector for $100 to $200 to assess the current condition. You are looking for the substrate condition underneath the surface where, if the decking is solid, the structure is sound, and the damage is limited to surface weathering, cracking, and minor leaks. Your roof is a candidate for coating. Step 2. Clean the surface. Pressure wash the entire roof surface to remove dirt, moss, algae, loose granules, and debris. The coating must bond to a clean surface. Allow 24 to 48 hours of dry weather after washing before applying coating. Repair any obvious damage. Recaulk exposed flashing. Patch any holes or gaps with roof cement or appropriate patching compound. The coating will seal minor cracks and seams, but larger defects should be pre-treated for best results. Step 3. Buy the coating. Go to any hardware store or home improvement center and buy Elastomeric roof coating. It is sold under multiple brand names, including Henry Harrisite, Gardner, and various store brands. Look for 100% acrylic elastomeric roof coating with Energy Star certification. A 5-gallon bucket costs $20 to $40 at most retailers. Coverage rate is approximately 50 to 75 square feet per gallon at proper to-coat thickness. For a 1,500 square foot roof, you will need approximately 4 to 6 5-gallon buckets. Total material cost, $80 to $240. Even at the high end, that is $240 versus $8,000 to $15,000 for replacement. 2% of the cost for comparable waterproofing performance lasting 15 to 20 years. Step 4. Apply the first coat. Using a standard paint roller with a thick nap cover or an airless sprayer. Apply the first coat of elastomeric coating across the entire roof surface. Work in manageable sections. Apply thick, even coverage. Do not thin the product. Pay special attention to seams, flashing edges, pipe penetrations, and any area where two surfaces meet. These are the most common leak points and benefit most from the seamless coating coverage. The first coat typically dries to touch within 2 to 4 hours, depending on temperature and humidity. Full cure takes 24 hours. Step 5. Apply the second coat. After the first coat has cured for a minimum of 24 hours, apply the second coat perpendicular to the direction of the first coat. If you rolled the first coat east to west, roll the second coat north to south. This crosshatch technique ensures complete coverage with no thin spots or holidays. 2 full coats at manufacturer-specified coverage rates are the minimum for rated waterproofing performance. Areas with known leak history or high-stress points benefit from a third coat. Step 6. Allow full cure. Allow 48 to 72 hours of dry weather after the final coat for complete cure. Once cured, the coating forms a seamless, elastic, waterproof membrane bonded to your entire roof surface. Walk the roof after curing and inspect for any areas that appear thin or missed. Touch up as needed with additional coating. Step 7. Maintain effortlessly. Inspect the coating annually. Look for any areas of wear, damage from fallen branches or accumulated debris. Clean debris off the surface to maintain reflectivity and prevent moisture trapping. If areas show wear after 10 to 15 years, apply a maintenance coat over the worn areas. You do not need to strip or remove the original coating. Simply clean the surface and apply a fresh coat directly on top. Each maintenance coat extends the waterproof performance further. A homeowner in Florida applied elastomeric coating to his 18-year-old shingle roof that had been leaking in 3 separate locations. 2 roofers had quoted him $11,500 and $13,200 for full replacement. He bought 5 5-gallon buckets of elastomeric coating for a total of $175 and spent one Saturday applying 2 coats with a paint roller. That was 8 years ago. The roof has not leaked once since. He estimates his total savings at over $12,000 after accounting for the $175 in materials and approximately $600 in reduced cooling costs over those 8 years. $175 in one Saturday versus $12,000 and a week of construction noise overhead. Same roof, same weather, same result. Because one approach sealed the existing surface and the other ripped it off and started over. Let me state these numbers one final time so they burn permanently into your memory. A $4 gallon of elastomeric roof coating creates a seamless, flexible, waterproof membrane that reflects 85% of solar heat and lasts 15 to 20 years. $80 to $240 coats an entire residential roof, applied in one weekend with a paint roller. No professional skills required. The coating reduces cooling costs by 10 to 40% annually. Over 20 years, that represents $2,400 to $9,600 in energy savings alone, more than paying for itself multiple times over. A full roof replacement costs $8,000 to $15,000, takes a week, requires professional crews, generates waste, and starts the same 20-year deterioration cycle all over again. The ancient Indus Valley civilization coated flat roofs with bitumen 5000 years ago, and the waterproofing survived 2 modern archaeological excavations. Roman engineers sealed aqueducts with pozzolanic coatings that held water for 2,000 years. Mediterranean cultures have maintained white-coated roofs for millennia. The Department of Energy documented the performance. Lawrence Berkeley National Laboratory confirmed 15 to 20-year service life. The EPA certified it as an Energy Star technology. The military uses it on installations across every climate zone on Earth, and a $56 billion. Roofing industry needs you to never pick up a roller and a $4 bucket of white coating, because the moment you do, their $12,000 replacement cycle ends at your property forever. This knowledge never disappeared from the planet. It was buried under roofing sales, presentations, and free inspection. Offers designed to find reasons for replacement instead of solutions for preservation. Buried under a business model where every dollar spent on coating is $12,000 lost in replacement revenue. Buried under an industry that inspects your roof the way a surgeon examines a patient while holding a scalpel. They are not looking for reasons to save it. They are looking for justification to operate. The Indus Valley builders knew 5,000 years ago they coated roofs with bitumen that archaeologists found still intact in the 20th century. Babylonian engineers knew they documented multi-layer roof coating systems on clay tablets in cuneiform script. Roman engineers knew they sealed roofs with pozzolanic coatings that have outlasted every modern roofing material by a factor of 10. Mediterranean and Middle Eastern cultures have known for millennia. Their white-coated roofs are the most iconic architectural image in the ancient world. The Department of Energy knows right now. They published the data. It is free. Lawrence Berkeley National Laboratory confirmed it. Oak Ridge tested it. Energy Star certified it. And the roofing contractor, who just quoted you $12,000 for a new roof, absolutely knows the elastomeric coating is on the shelf at the same supply house where he buys his shingles. But right here, right now, watching this video, you just learned the same waterproofing principle that has been protecting roofs since before the pyramids were built, and it costs less than a family dinner. Your great-grandparents coated their roof with lime every few years, and it lasted a lifetime. Then, a $56 billion industry convinced your generation that roofs are supposed to be replaced, not maintained. But today, sitting right here, you just ended the replacement cycle for good. If this video opened something for you, subscribe and share it with every homeowner you know who has ever looked up at a stained ceiling and felt their stomach drop. Every single share preserves what the roofing industry spent decades keeping off your radar. The next video drops soon. What is inside weighs even heavier.